Hello, today we're going to talk about properties of rectangles. So the first thing to know about rectangles is that if it's a rectangle, it's definitely a parallelogram. And that's why we're starting out by looking at this picture of a parallelogram. And we can change this around to make it look more like a stretched out parallelogram, or we can make it look more like a rectangular parallelogram. Now what I want you to do is, as I move this, I want you to look at the diagonals and the two half diagonals. So like this 20.3 and 20.3. Of course, we know that the diagonals of a parallelogram bisect each other, so these have to be the same. And the same thing with the 8.3 and the 8.3, they have to be the same. But watch what happens when I make the parallelogram look more like a rectangle. Those numbers, 10.5, 17.6, on the different diagonals are getting closer together, 12 and 16, 13 and 14, until finally when I actually make it a perfect rectangle, which is kind of hard to do, but how will I know when it's a perfect rectangle? When the two, all the pieces of the diagonals are the same. So now what happened here is when it was slanted, the diagonals have different lengths, and so each half of a diagonal was different. But when the sides are perpendicular, which is what a parallelogram, what a rectangle is when you have perpendicular or right angles at all four vertices. Now, both of the diagonals are, in this case, 28.4, right? And since the 28.4 length diagonals bisect each other, each half diagonal is exactly 14.2, and most importantly, they're all exactly the same. So what we're going to be looking at now is how this forms just two pairs of congruent triangles. Alright, so here's a couple of rectangles, and notice that what we just found out was that the diagonals, all four parts are going to be equal. And this it doesn't matter if it's a vertical rectangle or if it's a horizontal rectangle, all four pieces in this one are also equal. All four half diagonals are equal. Okay, so what this does is that this tells us that we have these sort of hourglasses. So here's one of the hourglasses this way. This is just a normal vertical hourglass. And what we have here is we have two triangles that are, one is right side up and one's upside down relative to each other, and they're both isosceles triangles, and therefore their base angles are also equal. So not only are these angles equal, but because they come from two triangles, and by the way, these are, let me put these two as equal. By SAS, the two triangles are the same, right? They're congruent. So if these two bottom base angles of the isosceles triangle are equal, then the ones on the top are not only equal to each other, but they're all the same as each other. Okay? And also it follows, we already know that in a parallelogram, which rectangles are, we know that opposite sides are congruent, so those are congruent. Those are congruent. And if you look at this sideways, you've got a couple more base angles here, and let's put 3 marks there, and these are all the same. All four of them are the same. And what else can we see? We can see that if we call this angle 1 and 2, we can also see that angle 1, the measure of angle 1 plus the measure of angle 2 equals what? Well, they make those right angles, which is what makes it a rectangle. Okay, the same thing is going on in a horizontal triangle. These are going to be equal, and all four of these will be the same with those two isosceles triangles that are vertical, and then the two isosceles triangles that are more like horizontal have also congruent base angles where all four of the angles are the same. And then you've also got a third angle here. These angles are equal to each other, so these are equal. And I didn't mention it on the other one, but these angles are also equal. And they're different from anything else on here, so we have to give it a different number of marks. So 1, 2, 3, 4, 1, 2, 3, 4. It gets a little bit busy, but that's because the triangles have different angles in them. Okay, oh, this needs a fourth one. All right, so now let's take a look at the properties of rectangles. Now we know that rectangles are parallelograms, and therefore they carry all 5 Well, one of them's a definition that opposite sides are parallel. That's your definition. And then the other 4 are properties. But these are all 5 properties of parallelogram. So those are all, they all are true of rectangles too. We are adding 2 more. First is the definition of a rectangle. So the definition is it just has 4 right angles. And we're adding that property that we saw, and the simplest form of that property is that the diagonals, not only do they bisect each other, which we already know because it's part of a parallelogram, but they're congruent to each other. So the diagonals are congruent. As we just saw, very importantly, that means that each half diagonal is also congruent, because they bisect each other and they're congruent. We're just going to do a couple of these examples. We're going to do this one right here, number 2. So let's take a look, and we're going to notice something here about this rectangle and all rectangles. Actually, for this one, there's no angles involved. This is just a question about sides. So we're going to focus on lengths here, and we know that all 4 of these, 1, 2, 3, 4, they're all the same. And so we know if one of them is 15, of course, all of them are 15. And we know that opposite sides are also the same. So if this is 27, then this is 27. So let's go ahead and see what we can name here. And so we've got AC is 30, right? 15 and 15. BD is also 30, 15 and 15. Plus it's the same. They're both diagonals. Segment BE is only this part, and that's 15. Segment AB is the one that we just marked 30. That's because angles, sides across from each other are the same, so not 30 but 27. And BC is now going to be the one that's a little bit more challenging. So BC is this one. And so what we have to notice for BC is we have to notice that there's a right triangle. And we know a little bit about right triangles. At this point, the main thing that we know about right triangles, besides that they have a right angle, is that the Pythagorean theorem works for them. So we have a triangle here that has one side, which is the hypotenuse, right across from the right angle. This side right here is the hypotenuse. So that's 30. So we know that c squared is equal to a squared plus b squared. In this case, 30 squared, that's the c, is equal to a squared, which would be like the 27, plus, we'll just call it b squared. We'll just call this temporarily, we'll call that b. All right, and then we apply a Pythagorean theorem to this, we get 900 is equal to 729, 27 squared, plus b squared. Subtract 729 from both sides, and you get b squared equals 171, and then b is the square root of 171. You can either put it like that, or you can put it in your calculator where you'll see that it's approximately 13.1. This is approximately equal to 13.1. Okay, all about sides, needs the Pythagorean theorem. In most problems with rectangles, you don't need the Pythagorean theorem, but every once in a while that will come up. All right, let's look at another one, and let's look at number 4. And this one is all about angles. So the first one was all about sides, and this one is all about angles. But there's a big difference. In the example that we just did, we were given a couple of pieces of information to start, and we got to build from there. In this example, we're only given one angle. So the question is one angle in a rectangle enough to be able to find the remaining angles? And the answer is always. Always. If you have one angle of a rectangle, you have enough information to find all the angles. Okay, so let's go ahead and do this middle part first. So in the middle part, we know we have vertical angles. So we know that this is 64 in here. We have 180 minus 64 to get those linear pairs. That's 116. So you know this is 116 and this is 116. And we basically got two different kinds of triangles. They're both isosceles, right? We know that these are all equal. So if we focus first on the bottom triangle, this one right here, it's an isosceles triangle with a vertex angle of 64 and equal base angles. And this is going to be the same angles up here. So we know that if we go 180 minus 64, which we already did, we get 116. Cut that in half and you get 58. So this angle down here, 58. These are all 58s. All right. Now you can either do the same exact thing with the other triangle, or you can notice that this angle down here, let's just call this right here, this angle is a 90-degree angle. So this one, let's call this angle right in here, will be 90 minus 58, which is 32. So this is going to be a 32-degree angle. These are all going to be 32-degree angles. And then you just go ahead and you find each angle that's named on the right, and we'll just fill them in. All the angles over here now are filled into the triangle, the rectangle. Okay, so there they are. Notice they all have degree symbols. They're all angles. First example, all about sides. Second example, all about angles. And the third example is going to use a little bit of algebra, so we're going to move down to this one right here. Okay, and so let's take a look at what we have. I'm going to zoom in a little bit so I have room to write these in. Now we're going to want to label the information that we're given onto the diagram as much as possible. So I'm going to put the VW. So VW is this bottom part of the diagonal, 9x minus 11, right here. And that is just this part right here, right? Just from V to W. Now SU goes all the way from S to U. So that's a whole diagonal. So these two are not going to be the same. We know that. And this is 16x minus 2. We know they're not going to be the same, but we know this also. We know that this, and this are all the same. So the red segment, SU, is twice as long as the blue segment, VW. So we could say that two of those VWs are 2 times 9x minus 11 is equal to 16x minus 2. And then go ahead and solve. Okay, so by solving, we see that x equals 5. I did have a little typo that I corrected here. I had accidentally, I think, just put 2 there. I didn't put 12. But we can see here it's supposed to be 12. All right, now that we've done that, we can find those little segments like the blue size segments. And if we need to double for our answer, we can double. And now we're looking for WT, so we're looking for one of the smaller segments. So we know that VW is equal to 9x minus 11. And we just found that x is 5, so let's put the 5 in there. And then we multiply, so we get 45 minus 11, which is 34. So VW, so let's say here, VW is equal to TW, or WT, which is 34. And that's the final answer. Okay, so remember we've got all the properties of parallelograms plus 2 more properties. Right angles and diagonals are congruent as 2 new properties just for rectangles. Okay, hope you found this video helpful.